What if the biggest limitation of electric vehicles was never the battery, but the way we think about energy itself? Picture this: an electric car that never needs to be plugged in. No charging stations. No range anxiety. No waiting. Just drive, day after day, while the vehicle quietly sustains its own power. For years, that idea has lived somewhere between science fiction and forbidden conversation. But now, a single breakthrough is forcing engineers, automakers, and governments to pay attention. It doesn't come from Silicon Valley. It doesn't come from Germany, China, or Tesla's labs. It comes from a place the global tech world rarely looks. The claim is bold: a compact system that can be integrated into existing electric vehicles, allowing them to continuously generate usable energy while in operation. Not solar panels. Not regenerative braking. Something entirely different, something that challenges how energy flow is measured, reused, and sustained inside a closed system. To understand why this is causing shockwaves, you first need to understand the problem every EV still faces. Electric vehicles are cleaner, quieter, and more efficient than combustion cars, but they're still dependent. Dependent on massive battery packs. Dependent on charging infrastructure. Dependent on power grids that, in many parts of the world, barely exist. Even in developed countries, charging times, grid strain, and battery degradation remain unsolved weaknesses. Now imagine removing that dependency. The breakthrough being discussed doesn't claim to create energy from nothing. Instead, it claims to capture, recycle, and stabilize multiple microenergy losses that normally disappear as heat, vibration, resistance, and electromagnetic waste. Losses engineers usually accept as unavoidable. Losses no one bothered to harvest until now. Inside an electric vehicle, energy is constantly moving, transforming, and leaking. Motors vibrate. Electronics radiate. Fields fluctuate. Traditional systems ignore this chaos. This new approach treats it as fuel. The idea is simple, but dangerous to the status quo. A modular unit sits between the drivetrain, power electronics, and battery management system. As the vehicle operates, the unit continuously captures specific energy patterns, conditions them, and feeds them back into the system in a controlled loop. Not enough to overcharge, not enough to break physical laws, but just enough to dramatically slow battery depletion. In some demonstrations, the battery level appears to remain nearly constant during long drives. That's where the controversy begins. Because if that effect scales, if it works outside the lab, if it survives independent verification, then every electric vehicle on Earth becomes obsolete overnight, or upgradable. Think about what that means. No more 400-mile range limits. No more billion-dollar charging networks. No more strategic lithium bottlenecks. And for automakers who built their entire future around selling new platforms instead of upgrading old ones, that's not innovation. That's disruption. Predictably, skepticism followed immediately. Engineers demanded data. Scientists asked for peer review. Media outlets questioned credibility. And yet, quietly, interest kept growing. Because behind closed doors, some people weren't laughing. Investors began requesting private demos. Governments started asking regulatory questions. And manufacturers, especially in regions with fragile power grids, started doing the math. If an EV could become largely self-sustaining, even partially, it wouldn't just change transportation. It would redefine energy independence. Rural regions without charging infrastructure would leapfrog entire development stages. Military logistics would change. Disaster response vehicles would no longer depend on fuel supply chains. Even aviation and maritime sectors started paying attention, not because they believed everything, but because ignoring it was too risky. And then came the most unsettling question of all. If this kind of system is even partially real, why hasn't something like it been pursued before? Some argue it has, but was dismissed because it didn't fit existing models. Others suggest that industries built around consumption don't move quickly to embrace efficiency that reduces demand. And a few believe that ideas like this tend to surface only when technology, materials, and computation finally catch up. Whatever the truth is, one thing is clear. This is no longer just about one inventor, one device, or one car. It's about whether the electric vehicle revolution is about clean energy or controlled energy. And as pressure builds for independent testing, public demonstrations, and real-world validation, the next phase of this story may be the most important yet. Because once this technology leaves controlled environments and enters everyday roads, there will be no room left for theory, only results. Because once results enter the real world, control slips away. The next phase doesn't happen in laboratories or conference halls. It happens on ordinary roads, under ordinary conditions, with ordinary drivers who don't care about theories, they care about whether the car keeps moving. And this is where the story quietly shifts. Reports begin to surface of pilot installations. Not publicized. Not advertised. Small fleets. Converted vehicles. Long-distance drives where charging stops are planned, but never used. Engineers watching dashboards more than the road, trying to understand why energy curves don't behave the way they're supposed to. Instead of the familiar slow decline, the battery stabilizes. Not frozen. Not increasing. Just refusing to drain at the expected rate. That subtle detail is everything. Because a system doesn't need to be fully self-powered to change the world. It only needs to reduce dependency enough to rewrite economics. Cut charging frequency by half, and infrastructure projections collapse. Cut it by 70%, and entire business models fail. Push it further, and suddenly energy becomes a background concern instead of the central limitation. This is why reactions are so divided. Publicly, many institutions stay cautious. Words like unverified, unproven, and theoretical dominate official statements. But privately, interest sharpens. Meetings happen. NDAs are signed. Technical teams are sent not to endorse, but to observe. Because if this breakthrough works even imperfectly, it exposes an uncomfortable truth. The future of EVs may not belong to those who build the biggest batteries, but to those who learn how to waste less energy. And waste is everywhere. In power electronics. In thermal dissipation. In magnetic inefficiencies. In signal noise. All tiny losses. All ignored. Until someone decided to listen to them. What makes this especially disruptive is compatibility. The system isn't presented as a new car. It's presented as a layer. A conversion. A retrofit. Something that could, in theory, be installed into millions of existing EVs already on the road. That's when resistance hardens. Because upgrades don't generate the same profits as replacements. Because decentralized energy control is harder to regulate. Because once drivers stop needing permission to move, leverage disappears. This is why the conversation increasingly shifts away from "is it possible?" to "who gets to decide?" If a self-sustaining EV becomes real, even partially, it challenges not just automakers, but utilities, regulators, raw material suppliers, and geopolitical strategies built around energy dependence. And that's why the silence is often louder than criticism. No official bans. No endorsements. Just delays. Requests for more data. Calls for further testing. Always one more step before acceptance. But history shows something important. When a technology threatens too many interests at once, it doesn't get debated. It gets slowed. Still, momentum is a stubborn thing. Every new demonstration, every logged mile, every unexplainable data set adds pressure. Online communities dissect footage frame by frame. Independent engineers run simulations. Critics argue fiercely, yet keep watching. Because deep down, everyone understands the same reality. If even one independent verification confirms sustained energy stabilization in an EV under real driving conditions, the conversation ends instantly. No marketing campaign can compete with physics. And somewhere between skepticism and silence, that confirmation is what the world is waiting for, because the moment it arrives, electric vehicles will no longer be defined by how far they can go. And that possibility changes how people behave long before it's officially confirmed. Drivers begin to imagine freedom not as speed or luxury, but as independence. No planning routes around chargers. No calculating battery percentages like a countdown clock. Just movement, continuous, predictable, quiet movement. Once that idea takes hold, it's almost impossible to put back in the box. Inside the industry, tension grows. Some engineers are fascinated. Others are uncomfortable. Because accepting this concept means admitting that decades of design choices were constrained not by physics alone, but by convention. That energy losses were treated as unavoidable simply because they were inconvenient to chase. And now someone is chasing them. What makes the situation even more delicate is timing. Governments around the world are locking in EV mandates, infrastructure spending, and long-term grid expansion plans. Entire national strategies are built on the assumption that charging demand will only increase. A technology that weakens that assumption doesn't just disrupt products, it destabilizes forecasts. So the response becomes careful. Not rejection. Not acceptance. Containment. The language shifts. Interesting but premature. Promising but needs oversight. Worth studying but not scalable. Yet behind those words, a quiet urgency grows, because the longer this idea survives scrutiny, the harder it becomes to dismiss. Independent testers start asking for access. Not influencers. Not marketers. People with nothing to gain and reputations to protect. People who only care about repeatable measurements. And that's the turning point everyone senses approaching. Because once data is collected outside controlled environments, once logs are published, methodologies shared, and assumptions challenged, this stops being a story and becomes a test. Either the numbers collapse, or something unprecedented emerges. What's rarely discussed is how small the threshold for disruption really is. This system doesn't need to make EVs infinite. It doesn't need to break thermodynamics. It only needs to shift the balance slightly, enough that the battery becomes a buffer instead of a fuel tank. That's a subtle difference, but a powerful one. A buffer smooths fluctuations. A fuel tank defines limits. Change that role, and everything downstream changes with it. Manufacturing priorities shift. Vehicle lifespans extend. Second-hand EV markets explode. Charging becomes optional, not essential. And once consumers experience that, even briefly, the demand won't disappear. That's why the coming phase is the most critical yet. Not the invention, not the claims, but the exposure. The moment this idea moves beyond controlled circles and into uncontrolled reality. Because technology doesn't need permission to spread. It only needs proof. And when proof arrives, whether it confirms everything or only part of it, the world won't return to the question of, is this possible? Once people begin asking why, attention turns away from the invention itself and toward the systems that decide which ideas get funded, tested, and deployed, and which quietly disappear. History is full of technologies that didn't fail because they were impossible, but because they were inconvenient. And this is where the story grows bigger than electric vehicles. If energy losses can be harvested inside an EV, then similar principles apply elsewhere. Trains, ships, industrial motors, even data centers. Any system where energy moves, vibrates, oscillates, or dissipates becomes a candidate for reconsideration. Suddenly, this isn't just about mobility, it's about efficiency at a scale no one prepared for. That realization makes people nervous. Because efficiency doesn't just save money. It redistributes power. Nations that rely on energy imports start imagining reduced dependence. Regions with weak grids see a chance to bypass massive infrastructure costs. Consumers, for the first time, glimpse a future where movement isn't metered minute by minute. And once people glimpse that future, patience wears thin. Online, discussions intensify. Some call it revolutionary. Others call it deception. But even the loudest critics can't ignore one detail. The idea refuses to die. Every attempt to dismiss it sparks more curiosity. Every attempt to bury it brings new eyes. That's often the sign of something dangerous. Not dangerous because it's false, but because if it's true, it forces too many changes at once. Meanwhile, development continues quietly. Refinements, smaller modules, better thermal control, cleaner integration with existing vehicle software. The language shifts from breakthrough to optimization, from revolution to implementation. That's how real technologies mature, away from headlines, toward reliability. What's striking is how little spectacle is involved. No flashy launches. No mass-market ads. No bold release dates. Just iteration. Because those closest to the technology understand something critical. The moment expectations outpace verification, credibility collapses. So progress stays measured, deliberate, almost cautious. But the pressure from the outside keeps building. Automakers can't afford to ignore it. Regulators can't afford to misunderstand it. And consumers, especially those already driving EVs, can't stop imagining what it would mean to upgrade what they already own instead of replacing it. That single idea, upgrading instead of buying new, might be the most disruptive of all, because it shifts value from manufacturers to users. And that's why the coming months matter more than the claims, more than the controversy, more than the personalities involved. What matters is whether this concept survives exposure to reality, heat, dust, vibration, time, misuse. If it does, even partially, the EV conversation changes forever. And if it doesn't, the questions it raised won't disappear. It shows up in the way engineers start speaking more carefully, in how interviews dodge specifics, in how documents reference efficiency enhancement systems instead of bold claims. The vocabulary becomes neutral, almost boring, because boring is safer than revolutionary. But beneath that surface, priorities shift. Research budgets quietly reallocate. Small teams are tasked with exploring loss recovery. Old papers are revisited. Abandoned ideas suddenly look less foolish. Concepts once labeled impractical are reclassified as premature. That's how paradigms move, not with announcements, but with reevaluation. What's fascinating is that this breakthrough doesn't demand belief. It demands measurement. And measurement has a way of cutting through ideology. Numbers don't care who invented them or where they came from. They only care about consistency. That's why the most important moments aren't press conferences, they're long, uneventful drives. Hours on highways. Stop-and-go traffic. Heat waves. Cold mornings. Real conditions that punish weak ideas and expose shortcuts. And in those moments, expectations quietly collide with outcomes. If the system fails, it will fail there without drama. If it works, it will work there without applause. That's the irony of truly disruptive technology. The bigger the impact, the quieter the proof. As this story continues unfolding, one thing becomes increasingly clear. The future of electric vehicles may not be decided by who builds the fastest car or the largest factory, but by who understands energy well enough to stop letting it escape unnoticed. Because energy has always been there, moving, vibrating, dissipating, because breakthroughs don't always arrive as finished products. Sometimes they arrive as questions powerful enough to unsettle everything built on old assumptions. This one asks whether electric vehicles must always be dependent, or whether dependency itself was a design choice. No matter how this technology ultimately resolves, one fact is already undeniable. The conversation has changed. Engineers are listening differently. Policymakers are hesitating. Automakers are watching instead of dismissing. And drivers are imagining a future that feels strangely closer than it did before. A future where range anxiety fades, where charging becomes optional, where efficiency, not excess, defines progress. Whether this system becomes the foundation of a new era or simply the spark that forces better ideas forward, its impact has already landed. Because once people start questioning where energy goes and who controls it, there's no undoing that awareness. The road ahead will demand proof, patience, and transparency. But whatever happens next, one thing is certain.